Okay. Yeah, there's a border, but I don't really understand. Because when I make it full screen, it's fine. Okay. Doesn't matter. I think this is where we wanted to be. So, curious to see how the text. I guess that's a little bit easier to see. I'm wondering if a new is a VBO int. I need to figure out var VBO equals new VBO int and VBO. This is it. This is what I was looking for the other day. 1 second. Okay, so I think this is what I was. Let's see, buffer. Buffer target. Oh yeah, there we go. Okay. So I kind of been doing this a little bit, but so we didn't finish this from. We'll carry this. We'll carry these two over. So let's this is day 3. We'll do these two things first since they were kind of on the docket for day 1 or day 2. We'll update the translation of the camera. And we'll start abstracting out camera object. Okay. So today we'll actually try to, we're going to start abstracting out some of this demonstration. Start trying to create something a little bit more robust and try to create some components that we can actually start to build out this this engine, this quote-unquote engine. And let's see here. So let's see. Okay. All right. Well, so the first thing that I was going to do, let's see, is let's move the camera around. So I think the best way we're going to be able to do this, let's see if we can. I wanted to like, we had this at 2.2 originally, so we were like kind of looking down at it, and I think that's actually going to be, oh, that's right, we're going, let's go -2. So it's a negative y, I believe. Why is that? Why are the y's flipped? Doesn't matter. The other thing for the view matrix, I think we want to do like a look at. So our eye is at our position. Our target is going to be the position of the cube, which is the origin. And our up vector is going to be just a regular up vector, I believe. Whoop. What, is that a method? No? A vector 3 unit y. Okay. So this should actually, it doesn't. Awesome. Wait, unless am I just setting that every time? Should we do negative? Well, I would have thought that this look at created I'm trying to think. I believe that we can. This is no longer the translation matrix. This is actually we're just going to call this view matrix. I wonder if we need the up relative. There's no way. Vector. Let's see. We can't. Okay, so we can create an up vector, I believe, by doing position minus target. So position, and we'll just do vector 3. Target equals new vector 3. 0, 0, 0. And we'll say, see, direction target minus position unit normalize. Yes. Okay. And I believe so. That's our forward. No, we don't have an. There's no way it could want. I think that just wants a regular up vector. The unit vector. Let's see. Well, we'll pass it manually and see what happens. 0, -1, 0. So do we rotate and then translate? Is that what the order matters? Yeah. So that's close. That's close to what we want. Although it's not quite centered, which is a little bit confusing. I mean, because even though all right, let's actually just try to let's see here. That's the best I could do. If you speak English, that would cut out a lot of time. I apologize. I know a lot of people on here can speak multiple languages. Unfortunately, I'm not that person. So let's see. Really what we want is to not have to use this every single time. So I wonder if you can get, let's see, I'm going to do a matrix 4 and look at matrix. So we'll add this look at matrix and the look at, I wonder if it has a forward. So kind of like a Minecraft simulation. So it is curious though that I was expecting there to be a way to extract a forward vector. But I guess that's just the same as doing. So we'll do look forward. Okay, this is what I'm gonna do. So we have a view matrix, and we're gonna have look at forward. Okay, so we're just gonna pretend as if we're gonna use this matrix to look at something one time, and then we're gonna move along that axis like backwards and forwards. And so the way that we're gonna do that is this is gonna be look at matrix. Where we are, I see. This is what's strange. So the I position, but then when I actually apply to the when I apply that translation, it's not looking at the dead center origin. It's looking kind of offset, which I don't know if that's. Anyway, so I think that the way that we can get just a forward matrix is just to multiply by unit x unit z. And we're about to, I guess we're about to find out, actually. So we want to do forward. Did I not create a variable here? I thought I did. Oh, look at forward. It might actually be, yes, it's in positive z. So that's, so what we're going to do here let's see, we want our increment to probably be like move increment we'll set as like actually move total, we're going to call it, and we'll start at 0, and then we'll just, we need to make it a float. We need to make it a float, float, plus equal 0.01. And so right here, this is where we'll basically have to create another translation each time for the view matrix. We actually this will become a little bit clearer in a second. I'm just trying to be a little bit efficient here, not anything crazy, but just enough that it's a little bit clear what I'm doing. Create translation. We're going to create it from the position. Okay. And then we're going to multiply that by translation. And this look at has already been done for us. Position, target, and negative vector 3.y unit y. Unit y is the equivalent of, I guess, an up vector, and so for compatibility reasons they renamed it to unit y. So that's our matrix. Look forward is our look at matrix, the rotation in which we're looking at this object, times the z unit vector, which is going to give us a vector along that. I mean, it's basically actually the same thing. This could have been done so much simpler. I'm just going a little bit brain dead. Target minus position, normalize. This is going to be our the same thing. It's just a unit vector between the 2 points that's in the direction of the 2 points, between the 2 points. So we have that. We have our translation. I already have this, so I don't need to use this copied version here. So look at times translation. Okay. So we set everything up, and then each frame we want to come in and we're gonna increment that move total, and we're just gonna say view matrix is equal. What do we want to add? Yes, this is actually gonna move really slow, I'm pretty sure. So that's what we wanted. We want that to be our position, actually. I'm just going to call translation position and create translation from that. Okay. This is also what we're going to do in the second one. So we're going to want our view matrix to be, I of course didn't make this one. This is ridiculous. So we will not need to recalculate that one because that one's going to stay the same. So the look at matrix, actually, yeah, that won't need to change, even though it seems like it might. It's not going to. So move total, we'll just, so we'll say that translation plus the equal, and we're just gonna we're gonna increment our position. This is actually gonna move us closer, so I wonder if that's fine for now. And then we're gonna recreate the translation, and we're just gonna use the same matrix. And then we gotta set our view matrix to the new value. Yay, that actually was pretty fast. I'm going to say if, let's see. If move total is less, we'll say then -20. Is less than -20, and it's got to be if move total is greater. Let's see, it's going in, so if it's greater than, it can't be both of those. It's not. It's got to be greater than -20 and less than 0. Then we're going to add. And then otherwise we'll subtract. So we should get like a ping pong effect here, or not at all. Oh, of course it starts at 0, so we'll do less than or equal. Okay. Why are we not hitting anything here? Less than or equal to 0. This is right. I'm pretty sure. So I'm gonna dump some logs and see where my basic math skills fall way short. What up? How's it going? 0. Oh, we need to start at -10. Wow, we went way far away. I wonder. This is okay. So number one, this is not right at all. Oh no, it is right. It is okay. I'm losing it. We're adding this. We're appending this to the -10 vector. So what I really probably need to check is this, not this. So if translation z is, we want it to start, so we'll just say is less than -10 and translation.z is So if it's moving backwards and it becomes less than -10, center equal -10, then we want it to flip to, but there's got to be another constraint. So if it's less than 10, -10, it's hard thinking in these negatives. Less than -10, and then once it arrives at 0, which would make it also no, this is the backwards way. So if it's coming backwards, there's no. This is ridiculous. We can just flip something. This is so ghetto. I think there's two conditions, and I think one of them is that I'm missing. So if forward, then we just want to move total is just plus equals 0.1f, and else move total minus equals 0.1f, and if forward and translation dot z, we'll flip it here. Translation dot z is greater than or equal to 0, then forward equals not forward, or forward equals false. Actually, we need to put this as this got to be an inner condition. No, it doesn't. No, it doesn't. Else if forward, if not forward, and translation z is less than or equal to -10. Okay, so this should be what I want. Come back. Should come back again. There we go. Why my tiny little math noggin couldn't wrap around that, I don't know, but so what's interesting, I guess, in this position is that we are moving the camera, but like let's see if we can switch some of the constraints here to like 5 and 5. I think this is going to keep it a little bit tighter. But here's the thing, is it still doesn't seem correct. And I'm not absolutely sure why that is. Because if we remove these lines to update, we'll just comment these things out right here. So if we just remove all of this and we just want it to show, so our cube is just rotating in a single place. But what's interesting though is that the camera is placed at 2, 2, -10. So back on the z-axis and then up and to the left. And so the cube is at the origin. But my look at matrix, which is here. Oh, interesting. I wonder what unit Y returns. We can console it, or we can debug it, either one, but let's just do vector 3.unitY. I'm curious. Oh, semicolon. I'm just curious to see here. So it's a positive. So I wonder why my axis is flipped. So if my translation, I wonder if that rotation matrix, if the look at matrix is actually a translation and rotation. Let's try that. Let's see if that's what it is. Whoops. Move this back here. Wait, why is position? Oh, goodness. I was updating it here. So it is. So that look at matrix is actually baking translation. That's why it was wrong. Because I was trying to apply the translation. The look at matrix is actually both rotation and translation. Which is handy. I mean, that's fine. I mean, most of the time I guess you want that, but I just did not realize that at first. So, okay, fine with me. And now I wonder if we add this back. The only problem is now we can't update separately a translation matrix. We would actually have to recreate this each time. So translation is actually that. We'll just keep the origin the same. We don't need this line. So, okay. Look at translation, target, then our view matrix. We actually don't even need this anymore. We can just do this. And then our view matrix will need to update each time with the updated translation. And oops. Here I'm using obsolete properties. Okay, so this moves way too fast. We don't even need move total. We can just use translation Z directly and translation Z minus equal. So now I need to probably give it some better constraints, like -20. So it's interesting. We're actually kind of going into the cube and then through it. And it's looking at it every single time. But that little double take you see it do, I'm pretty sure it's going through it and it's kind of rotating around and looking at it. Translation Z. Well, we have it set so that it's, oh. This should actually be negative. Well, we'll do a negative 2.5. And 15. This actually should keep it at bay instead of like going through it. So this is kind of, I guess this is kind of what we want. Now, it is interesting. I can probably extract rotation from a matrix 4 object. Like the translation is just the fourth component, I'm pretty sure, the fourth column. My linear algebra is way out of practice, so anyone in here who has any sort of recollection of early day math, please remind me. So it would also be nice to know what angle is. So we can create a lookout, rotate. Those are all static helpers. But once we get like a matrix 4, I think the only thing it supplies us is the operators. There's an inverse, transpose. Yeah, everything else is. Wait, what is this? So we're gonna do a small test. And this should actually be 3, right? Yeah. Those are super tiny numbers. So this is basically our translation. the first two, yeah. So this is our translation. So really, if we wanted to, we could extract the translation element. In fact, I wonder if we. Because the thing that's kind of what I wanted it to do was move in more of a linear fashion. And what I mean by that is I wanted to get the rotation, and I wanted to do the look at, but instead of like always updating the look at to always be facing the thing, what I really wanted was just to always face it once and then move the camera in just the forward direction, just the forward vector. So that's why like this look at is super helpful, because it includes the translation in the matrix calculation. And to be honest, like, I don't know how normal that is. Maybe it's normal, and I'm just out of practice here because, let's see. So I think, so I prototyped this guy in C++ early on, but I rolled all my own math stuff so that I would I would have some refresher. And I ran into a ton of derp moments when I was prototyping this thing because it had been so long. I still, to this day, it's like, all right, so here's, yeah, so when I wrote the look at, it took the exact same components, but it always set the third row to, it always zeroed out. It's always basically the third row. It just includes the XYZ axis rotation. So we could, I'm completely lying because I did apply the translation. Huh. Never mind, I'm lying. I did apply. I did apply I create a rotation matrix, then I apply the translation. Okay. I'm okay with that then. All right. Okay, so let's maybe start trying to abstract. Let's make this truly start to try to let it take some form here. So the other thing that I wanted to do that I didn't do last time was look at forwards never used either. Oops. So I did want to update like something. Let's see. Yeah, we never use this. No. So we have this blue color. We could make it do something interesting. See if I have. I don't think I have a really good diffuse lighting. We can do something like uniform vec3 light position. And we can say, I can't remember exactly how. Vert norm and text chord. Yeah, how did I do that? How did I do that? Do you set it as let's see. I need to look up fragment shader. It's always based on the state on the version that you use. And I believe it's out and in, but man, attribute is used to declare variables that are shared between the vertex shader and the OpenGLES environment. Since the vertex shader is executed one time for each vertex used to specify vertex data, they typically provide data such as object space position. Okay. Uniform, the qualifier uniforms declare variables that are shared between the shader, blah, blah, blah. Uniforms can be used in the vertex shader and fragment shader, and they must have global scope. The same uniform variable can be used in the vertex and fragment shader, but since both shaders share the same namespace, the declaration has to be identical. Varying. The qualifier varying is used to declare variables that are shared. Okay, thank you. Varying are used information that is calculated in the vertex shader and should be handed to the fragment shader. Okay, that's what I need then. Varying, it sounds like. But okay, so that is what I need. So we'll say we'll call this like vec3, and we'll call this the, let's see, light intensity. The light position will actually need to change to come over here as a uniform. In position, let's see, light intensity, and we want to say, we want light position. See, back 3. Let's light. This is gonna be delta. No, but I should try that. So it's in and out, and then in out, right? Yeah, all this stuff is hard. It's hard. It's so hard to keep track of the GLSL versions and conventions and what's in or what's new and what's old and what you should be using and what you shouldn't be using, and it's so confusing. So uniform is still a thing. In is still a thing. So is in out the combination of is in out the replacement for varying? And in is the replacement for attribute? Can't keep track of it all. It's making my head hurt. Well, I'll see if varying works, and then once we get it working, we'll try to substitute out for the newer standards. Because I do want to be somewhat up to date here. Because I do remember varying and all that stuff being out of date. But once mobile came into the picture, it became really convoluted. Because mobile supported like subsets, and it was just like it just became, and then especially with Android and Android support of all these different GPUs and stuff, it just became a complete catastrophe. So the light position minus the in. Actually, we want to do it after the. We'll do the applied model. There are tricks you can do. I just can't remember. Let's see. Like, can't you do like XYZ? I think you can. I think you can do like Y, XYZ, XZZ. I think you can do all sorts of stuff. Let's see, Vex. Is there magnitude? I just need you know what I need? A GSL SL cheat sheet. That's what I need. I don't need anything else. I just need a cheat sheet, a reference, a quick guide. Right. It should be out vec3 and fragment shader should be in vec3. Oh, okay. Oh, man, I could just do this. Actually, I wanted this to be just a float, I believe. I mean, it's probably better that if it was like a colored light that we could control the channels, but I don't really care right now. I'm trying to just... So light intensity can equal distance between these two. That's really all I wanted, is just distance. And then color. I wonder. Maybe we should do it like come up with like some random value, like 50. This is not going to work. I just have this feeling. I got this feeling inside my bones. We'll just say, we'll put it at like new vector 3. We'll just say it's at like 10, 15, and then we'll offset this a little bit, like -10. That sounds good to me. No, I don't want to do, no. Light position, not light intensity, light position. I can't believe that worked. I feel so accomplished that worked the first time I tried it. In Vec3 light intensity. So part of me was expecting, though, it seems like this would be a little bit more of shaded. I feel like it's constant. I feel like it's been so let's okay, it didn't compile. I wonder if we're requesting like a specific I wonder if we can like put like a version, a specific version at the top. All right, you know what? Let's okay. It'll be interesting to see. God, this is not the keyboard that I normally use for this, but let's see, 130 you said? Is this throwing? It's like I'm trying to make this difficult on myself. Okay, so it accepted the version, which is good. So let's say out and then in. Hey, sweet. Okay, so what about 140? Seems to like 140 too. Really and truly, what we should probably be doing is all right. So this is the little OpenGL interop wrapper I'm using. And I was just gonna look. It uses SDL internally. I was gonna look and see. Oh, I hate these things. Vertical sync. Create window. I wonder if we. It doesn't look like we're going for any sort of create context. Doesn't look like we're able to pass any sort of profile request. Meh. So, wonder if can I get the context? That's input, reshape, and close, mouse, keyboard callbacks. No, that's not what I want. Man, like I love managed languages. Like I love CSharp. But like this is what I really don't like about it. I should just pull this source, these projects into my project. Window full screen. I thought that you could pass. So 1 second, because I have, when I prototype this thing, it's funny, when I prototype this thing in C++, I used SDL. And I was making it cross-platform. I don't think that this one is going to be cross-platform because .NET is such a mess right now that I don't even really feel like screwing with it. But when I was making this cross-platform, I was testing on a Mac that was old as dirt, and I was also testing on just a Windows PC, and they were completely different in terms of graphic support. And so I was kind of forced to make the GL context creation and the shaders and everything be very, or at least be aware enough to know what target they were on and how to react. But I'm truthfully not. Yeah. Okay. So sorry. I know I'm looking off screen. You can't see what I'm looking at, but here I'll show you what I'm looking at. I refactored a lot of this so that it would use so it looks like I was always trying for at least 3.2 GL. I wonder what this is. Context minor version. Wait, that's minor version. Minor. Okay, this is like a hack fix based on what I'm reading right now. This is like a hack fix for OS X, which is why it's in there. That makes sense. Okay. Sorry. I'm trying to I wish I could figure out compatibility wise. This sounds like an interesting compatibility object. Detect valid resolutions, Darwin, OS X Windows. I really appreciate this guy's programming, man. He is, you can tell he cares a lot about what he does. It matters to me. I'm glad that he made the effort here. So this guy, the guy that wrote like this, I mean, it's open source. He wrote like a little platform. He actually wrote like a GL like a GL platform and a UI system, and just open sourced it, and just did an incredible job. Mainly, and he did an incredible job knowing that how can I get information about the context? That's what I want. He wrote this for a personal project, and then he open sourced it, and it's like he went through, spent time, and made it like a good open source project, which is amazing. Let me figure out how to get context information. Because I mean, it matters, right? I mean, you have to. I don't know which version of OpenGL I'm using. GL get string version. Easy enough. So let's see if we can grab that information. So I need to minimize this, get back into our app here, and then get string, and then GL version, open GL dot. Oh God, I miss. Is this for real? Does he have constants? He's got to. There's no way he just didn't. GL core. No GL version there. Oh, here we go. major version, minor version, version. And then there's shading language version. Okay, so what is its string name? OpenGL string name. Okay. String name version. And I probably should wait. All right, we already got the window and everything, and then we'll just console right line. Okay, OpenGL version, and then version. Okay, so I'm pretty high up there, right? That's a pretty 4.5. It's the latest. So the world is my playground. Sounds like. And then right line. SL version. GL.get string name shading language version. And I'm going to just go ahead and just put this in here. And we'll just make this let's make this like some sort of debug dump. Do, 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 do. 440. Wow. So I'm putting version 140 here, and I can actually do up to 440. Holy moly. That's I mean, clearly I think I'm going to want to maximize compatibility. I don't know if I'm going to want to use the absolute latest and greatest. Okay. They have nice little reference cards. Look at this little guy. It's a good looking little cheat sheet right here. So I'm going to keep this little cheat sheet up for now. So Project Vulcan, a giant. It's funny when you. I know it's different, but whenever you said that, this is Oh, I'm gonna tell you. I'll show you what I This is what I think of. A giant drill that can drill to the center of the universe. I shall call it Project Vulcan. Anyway, it's my daily humor. So I got the cheat sheet open for this version of OpenGL, and it's like it is enormous. Like the one that I was just looking at was like 1 page, and it is now like so deep. Holy moly. There's an atomic UINT counter type now. A U image 2D multi-sampling array. Are you kidding? They're just making it all so easy now. It used to be so hard. I mean, to make that compatible with a lot of stuff, you'd have to do a lot of work. Okay, so qualifiers. So these are the latest qualifiers. Wow, it definitely just dumped them all into thanks, Twitch chat. It looks like const is read-only, in linkage into shader from previous stage, out linkage into shader from next stage, uniform, buffer. Buffer is only accessible by shaders and the OpenGL API. And then shared, compute shaders only, shared among work items in local group. Auxiliary storage centroid, sampler, and a patch. Interface blocks, in, out, uniform. Layout, qualifiers. Tessellation. Okay, so let's make this. So uniform is still right. Attribute is now in. Out is out. In float. No. So this is all right. Now I just want to figure out why. This would be a vector 4, XYZ. I want to know why. I wonder what this distance is. That's what I really need to figure out. Let's make this bigger, like 100. So what I'm trying to figure out here is this. There are what? 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4, 8. There's 8 vertices, right? In a cube. 8 vertices. If they share vertices, I guess it's 8. But either way, it's going to check the distance between all of those and my light source. And let's just say that it's the maximum distance between a vertex and the light source is going to be from -1, 1, 1. So like, or maybe it's -1. It's one of those, but like the biggest difference between the light intensity on each vertex is just going to be 1 squared plus 1 squared plus 1 squared. I guess 3. Yeah. Or something. So I guess what I'm really trying to figure out is how I can make one side it just doesn't seem like it's smooth. Like it seems like it's all getting the same application. What is color all floats and they're all to 1? I'm just trying to figure out how I could change the intensity in a way that would make more of a dramatic I really just like simple diffuse shading. I think I'm going to have to actually use okay, so the cosine of the angle between the normal and the light direction. So we do need light direction. So let's do this. Let's do alt vec3 and we'll call it light direction. And we'll make this vec3 light direction, and then is the clamp is the dot product. Let's see, what is I wonder if you can in position. I want to know what it's passing. Let's see. Let me go to where's shader program. Attach shader. Just want to know what it's how it's passing in position. Is that a default? Is in position like a default for OpenGL? If I hold on, I can do this because if I break the shader, like add something broken in there, Where is that? Bind attributes. I think that's what I was doing. Yeah, here we go. Yes. Thank you. Thank you. In normal, in UV, in tangent. So I do need the normal. Awesome. Had to break it to find the code. Makes perfect sense. And then we'll do in vec3 in normal. And then the so what we want to do is just, it looks like we just take the dot product. Let's see, cosine theta. Actually, we still want light intensity maybe. So let's, we'll do light out float light intensity. And we'll do in float light intensity. Light direction we don't really care about, I don't think. Light color. So light intensity, and then the dot product is going to return light. We'll just say, we'll call it cosine theta because that's what it is. In float cosine theta, and then we'll say that our, is color a type? No, it's not, I don't think. We'll just say that our vec3 light color is going to be light intensity times cosine theta times color. And cosine theta is going to be in normal 1, 0, 1. No! I broke something. All right, so wait a second. So in normal is vector 3. Dot product takes a vector 3. You know, having an exception there might not be a bad idea for the shader. I don't know why we don't have something. Let's see. So new shader program. I was hoping it was going to like have a log or something that would tell me if I screwed something up. But it doesn't look like it is. So, I wonder how I can get that error information. Be a whole lot easier to debug if this was the case. So light color is equal blah, blah, blah. In cosine theta light intensity. Those are both right. In normal is fine. It's something with this, maybe. Let's just start with this. Start with that. No, even that's wrong. Let's just call it 0 then, or 1. Okay, so it's definitely that dot product. Well, why? Light direction. Is there a normalize? Yep. Is the dot product of in normal light direction it did something. So maybe I should just say this is always 1 for now. Oh man, it seems to be so. I wish you could debug these things. Like I really want to know what that is. What is that in normal? This just, it seems right, so. Okay. Huh. So. I mean, like, I'm guessing this would have to be normalized. So, but what's interesting here, so maybe I need to clamp between 0 and 1. So say float theta equals clamp cosine theta between 0 and 1f. And we'll just try this. This is what's really interesting to me is no. Oh, gosh, that's why. It's 1.0f. Duh. Come on, man. Get with a show, Bolt. Jeez. This is starting to make less and less sense to me. Because if I'm clamping it between these two values and light intensity is 1, then why? Then how could it not show anything? So it's light intensity? Am I crazy? Am I crazy here? That's just a 1. What happened to all my stuff? Something's failing. Is it my comments? Can I not comment this stuff out? I mean, if I just switch this back to color. Wow. Okay. We're back in business. I feel like something's failing again. That's good. That's good. All right, we're doing okay here. This is not going to be good. Okay, so that's still good. Now it's not good again. Why not? Why is this line causing everything to break? Is in normal wrong? Do I need to apply? No. These are all fine. All of this is fine because I'm doing it in the same coordinate space. I'm doing all this in the same coordinate space, so this like dot product is blowing up. That's what I can't figure out. Let me do it on. I'm gonna do it on the CPU and see what it churns out. So I need to know. So if I did like, I don't believe I need to save this every time. So if I did like, let's see, so my model matrix is basically 0 times. So really what I'm looking at is I'm literally looking at like a point like this. So new vector 3, and it'd be like 1, 1, 1. That would be one vertex. And then because even with the applied, so, and we're saying that the light, let's do this. Var light positioned. I need to figure out a way to debug this, or debug GSL or GLSL or whatever, before not too long. And we want a light position, and V1 is that, and we, in our shader, we're saying that the light direction is equal to, I think we're doing it, I don't think it matters, light position applied light is equal light position minus V1 normalize, and then we're doing the dot product. I guess the normal for here would be, I mean, for most part, I think it's going to be, let's see, n is going to be, I think it's negative y in this case. One's unit y. And then var cosine theta is going to equal to vector 3 dot in light dir. And we're going to just write it out. And then we'll cosine theta. It's negative, which is probably, so I wonder, that's, no, because the light position, what would it even matter? I mean, if I flipped the y, it does matter. So let's try flipping the y here. No, it's the actual. What is wrong with this? Is this 0? I mean, we're not even. The thing is, it's like almost like it's throwing an error here because. But either way, the thing that's screwing up, man, is the fact that like we're not seeing anything, and we're not see this cosine theta. We're passing it through, but we're not even applying it. It's almost like the fragment shader dies on that dot. So the clamp is broken? Am I using the wrong syntax for clamp? No. I'm not. Maybe I am. No. Yeah, that doesn't make sense. There's some type of error happening, but it's still letting me continue, which is weird. I would expect if the fragment shader died that the whole thing would die. But like this is nothing's wrong with this. Like this is legitimate. It I don't even get it. If we even use this variable, it's blowing up. Like if I had like something like this, like float a is equal to cosine theta plus 0.5, it's not going to work. Let's maybe go back to like, let's like try going back like a version or something. Or maybe we can go back to 140 or 130. I don't understand why that value is not. It just, that makes no sense to me. Like, what if I set this to like 1? Okay. So it's whatever the dot product is generating. Is a problem. But why? What is a way that I can? You know what? Let's try this. This is gonna be a little bit different, but I'm gonna pass in normal. I'm just gonna pass the normal in here. out vec 3 normal, and let's say I'm just gonna say normal goes in normal. I don't know. No, that's a vec 3. That doesn't matter. That's stupid. Okay. In normal, and then I'm just gonna set it to the normal. I can't do that, right? I can't do that because I think it's the normal that's the problem. I think the normal is coming in is something superiorly wrong. I don't think the in normal is actually. Let's look at that section again. Attribute location in normal. Bind vertex, bind buffer, normal ID, pointer type, true 12, normal. So I don't know if anyone has any ideas. I'm virtually lost at this point. I don't really understand unless, you know, it's something to do with I could look at like there's a class called geometry. Cube. Okay. This would explain why. Because it's not actually passing in the normals. So let's actually do that. Okay, yeah, let's do that. So let's create our own cube. That's what the problem is that in normal is completely jacked up. Private static. So we'll do VAO and we'll do create cube and we'll do shader program and we'll do vector 3 min vector 3 max, and we'll just do basically the same thing, and except for that then we'll do calculate was it geometry, calculate normals, and we'll need to vertex and element, and then we shall need to vector 3 normals. Then we need to new VBO vector 3 normals. Yes, this is right. So we want to create. Okay, so we got all this done now. We don't need that. And we can go back into, wait, where's our create cube? Here it is. So we'll just do a create cube. We'll do our own. We'll do this dot product. Actually, we'll just make sure the normals are getting passed in now, and they're clearly not. Oh, it's because I still have this syntax here. Hey, look at there. Okay. So now that that's all getting passed in right, we'll do cosine theta, and we will, is it negative light direction? No. Oh, we don't need to do the end normal anymore. We'll just do that. Get rid of this. We shall do clamp theta equals clamp cosine theta 0.0 and 1.0. And theta times light intensity times color. And that's close. Is it? It's really close. It's like the normals are wrong. Why are the normals wrong? Does that even change it? It does. You're right. So it is negative light position. Or light direction. So interesting. Have to figure that out. I don't know. But I have to go because I start work in about 5 minutes. But we're getting there. For some reason, calculate normals doesn't appear to be actually calculating normals like it should. Calculate normal. See you later. Thanks for hanging out, man. Yeah, you can go back and watch it. It wasn't it was mostly just me kind of beating my head against the wall like last time as well. Yeah. Anyway, guys, I'm gonna bounce, but I will talk to you guys later. Thanks again for tuning in, and I'll probably be back in a few days. Take care.